This is the one that I got from the Berkeley math tournament, where I was a guest this year, about like 6 weeks ago in November on Berkeley campus for the integration B for with high school students. So Berkeley math tournament people, if you guys are watching, this is for you guys, and also all the participants. You guys are awesome. So here's the one. Integral going from 0 to 2. And we have x times the square root. It's a big square root. It's an infinite square root. It keeps on going on forever. And then we have x to the ln x power. And then inside here we have cube root. And again, this right here keeps on going forever. And we have x, not to the ln x power though, but rather ln second power x. So it means ln x squared. And then let's do it again. Fourth root, x to the ln third power x, and so on, so on, so on. The next one will be the fifth root, but we see the pattern already. So this is it. And we have the dx. This is the question. Shout out to the one who came up with this question. And shout out to all the Berkeley math tournament people, and also shout out to all the Instagram, shout out to all my Instagram followers and Jian and Ming for sending me your solution. And here is perhaps I will say the cleanest solution for this question. Anyway, let's clean up this expression. If it's infinite, you will know it's something about infinite series. So we are looking at the integral going from 0 to 2. This is x to the first, yeah? Next, I'm going to look at this as x. This is ln x instead of the square root, which is the 1/2 power. So we can look at this as ln x over 2 times the next one, it's x. This is ln second power x over 3 for the cube root, but then over 2 for the square root, and you multiply, so it's over 3 times 2. And you kind of see the pattern, it's not so bad, huh? Multiply x, and then ln 3x third power technically, and then fourth root, right? So like this, and so on, so on, so on, and then dx. Alright, so how do we deal with this? Let's put this down in the summation form. So this right here is the integral going from 0 to 2. X is x, and I'm going to write this as the summation. Let me use n going from, let me use n equals 1 to infinity. And we see that here we have ln x, but this right here does not have any ln, right? So it's technically n minus 1 power over, this is 1, this is 2, this is 3 to 1 technically, 4, 3 to 1, aka factorial. So this right here is the same as n factorial. Yeah, and then we have the dx here. So now the question is, how do we simplify this? I will tell you. We should know that when we have the series as n goes from 0 to infinity of x to the nth power over n factorial, this right here gives us nicely the nice e to the x function, and this works for any x value, right? This works for all x value. So they are quite similar, except for here we have ln x and this is x. Also, this starts with 1, this starts with 0. So let's fix this a little bit. If you want to start with 1, it's okay. You can write it out. The first term of this is just 1, and then this is you plug in when n is equal to 0. And then the remaining is the summation, n goes from 1 to infinity of x to the nth power over n factorial. This is equal to e to the x. Put this to the other side. We see the summation, n goes from 1 to infinity. Let me still use the red x here. X to the nth power over n factorial is equal to e to the x minus 1. That's okay. Okay, And then how should we deal with the -1 though? Let me show you. Right here, I can write this as the integral going from 0 to 2, x, and then this is the same as saying this, 1 over ln x times, because here it's in the n world, right here, you can put the x on the outside. I know this has the n, but that's ln, yeah. N goes from 1 to infinity, and then this is ln x, and we can put the n right here over n factorial, and then we have the dx. So how does this help? This is the integral going from 0 to 2, x. Here we have 1 over ln x. And this thing here is when x being equal to ln x. So we can just have the following. Summation, n goes from 1 to infinity, ln x raised to the n over n factorial. This right here is just what? E to the ln x power minus 1, aka x minus 1. So this thing here is just x minus 1. Good. But it doesn't look any better, right? It does, trust me. Right here, for the x, we can do the following. We can write this as integral going from 0 to 2. Look at the x as e to the ln x power. Very cool, huh? And then we take this, raised to the power of that. Namely, we have the over ln x here, and then the top here is x minus 1. And then we have the dx. So now what? The ln x and the ln x cancel. So in fact, this is actually just asking you to integrate from 0 to 2. And we have e to the x minus 1 dx. How do we integrate e to the x minus 1? It's just e to the x minus 1. And we go from 0 to 2. And now let's do this in our head. Put 2 in here, we get e to the first. Put 0, we get minus 1 for the power, and it's minus, so it's e to the negative 1, and that is 1 over e, and then we are done.